I'd like to welcome two special guests joining us virtually this evening. The Dean of the School of Health and Rehabilitation Sciences, Anthony DeLito, and Dr. Herb Rubin, who served as chair of the Department of Communication, as well as the Associate Dean of Graduate Studies in the School of Arts and Sciences at the university prior to his retirement in 1991. Next, I'd like to acknowledge those involved in planning and preparations for tonight's event. Dr. Mark D. Ryder, Professor and Director of our Clinical Doctoral Program in Speech Language Pathology, and also Director of Continuing Education in the department. Sharon Joyner, CSD Academic Affairs Administrator, Dr. Katie Bellardi, CSD Research Administrator, and Victoria Kimmel, Executive Assistant to the Department Chair. Next, I'd like to share with you a brief history of the lecture series. The Matthews Rubin Endowment Fund was established in 1988 under the direction of Herb Rubin and Betty Jane McWilliams. The purpose of the endowment was to honor Dr. Jack Matthews, who established the graduate program in audiology and speech language pathology at the University of Pittsburgh. And Dr. Matthews chaired the Department of Speech from 1955 until his retirement in 1987. In 1991, Dr. Herb Rubin retired after 32 years at the university. During this time, he served as chair of the Department of Communication, as well as Associate Dean of Graduate Studies. When Dr. Rubin retired, his co-workers and friends established a fund to honor his many contributions to them, to the department, and to the university. In 1996, the Department of Communication Science and Disorders found a new home in the School of Health and Rehabilitation Sciences, and with the blessing of Drs. Matthews and Rubin, the Matthews Endowment Fund and the Rubin Fund were combined and renamed the Matthews-Rubin Endowment. The Matthews-Rubin Lecture Series is one of those projects that the endowment supports each year. The fund also allocates an award to a graduate student who has achieved outstanding clinical performance, and that award is called the Lisa Levy Award. And now I'd like to introduce our distinguished speaker, Dr. Elena Plante. Dr. Plante is a world-renowned researcher and speech-language pathologist. She specializes in developmental language disorders in children and adults. Dr. Plante currently serves as the Vice President for Science and Research of the American Speech Language and Hearing Association. She has also previously served as department head of the Department of Speech Language and Hearing Sciences at the University of Arizona, where she currently serves as professor, principal investigator, and director of the Plante Laboratory. Dr. Plante also holds an affiliation with the Cognitive Science program at the university. She is co-author of several standardized tests for children with language disorders, including the pediatric test of brain injury, the test of integrated language and literacy skills, the SPELT, and the shirts and shoes test. Her lab is actively engaged in treatment research to improve grammatical morpheme skills in preschool children with developmental language disorder. Dr. Plante's work has been funded by grants from the National Institute on Deafness and Other Communication Disorders, the National Institute on Aging, and the Institute for Educational Science. In her spare time, she teaches courses in evaluation in speech-language pathology, school-age developmental language disorders, and grant writing, which, given her more than 30-year history of successfully winning grants, is a good thing for our field and for the field's junior scientists. And in fact, she'll be joining us on Wednesday during our PhD research roundtable to give her words of wisdom and advice to our junior scientists or PhD students and postdoctoral research fellows. We'll have a 10 to 15 minute Q&A period at the end of Dr. Plante's lecture. Dr. D. Ryder will be moderating the Q&A. If you have a question for Dr. Plante, just drop it into the chat box to Dr. D. Ryder privately, and he'll filter through those questions and answer or ask those of Dr. Plante at the end. So we look forward to Dr. Plante's lecture today on tricking the brain into near effortless learning. And without further ado, please join me in welcoming our speaker this year for our 22nd annual Matthews Rubin Lecture, Dr. Elena Plante.
Hi, I see some familiar faces, so that's great. I'm going to just share my screen here and we'll get going. So we'll see if this works. Yes, it did. Okay, well, welcome from Tucson, where I live and am currently. Looks a little different from where you are. So instead of nice green trees, we have saguaro. Instead of, say, a staghorn sumac, we have these cholla in the front. So this is my environment here, so you can sort of appreciate where I'm coming from. So we're going to launch right into this with something I'm going to ask you to ask yourselves. How many of you believe in your heart of hearts that language is hard for adults to learn? Well, I'm going to tell you that it isn't. And I'm going to prove it to you. We're not just going to tell you, I'm going to prove it to you. So for the next 20 seconds or so, you're going to hear some Norwegian from my colleague and friend Arva Asbjornsen at the University of Bergen. And just sit back, enjoy. While you're listening, you can enjoy an image of the harbor at Bergen, which is a World UNESCO Heritage Site. So let's just get going.
Brikke kan være så mangt. Dronningen en anvendelig brikke. En brikke I spillet. Hun viste oss en gammel brikke av glass. Hva slags brikke kan hoppe 2 frem og 1 til siden? Hvilken brikke kan flytte lengst på sjakkbrettet?
Okay, I'm hoping everybody heard that. Is that correct? Okay, sorry about that. I am not seeing, let me just see, get on a, I need to do something here. Okay, moving on.
Brikke kan være så mangt.
Didn't mean to play that again. So now, pop quiz, all right? So your job, having been told nothing about what to do, is to tell me. I'm going to play a test item, and in the chat box, what I want you to do is to indicate whether you think item 1 is a real Norwegian word or if I just made it up. Okay, so let's play this.
Brikke.
So yes or no in the chat box, real Norwegian word, or did I just make it up? And I am trying to get to the chat box and not being successful. Bear with me just a minute so I can.
Well, Elena, I can tell you there are many real responses and yeses coming through if you're unable to.
Okay, all right, thank you. I may have to rely on you for the next test item as well. So tell me if this is a real test item or if I just made it up.
Melbri.
Let me play that one again.
Melbri.
Is that a real Norwegian item or did I just make it up? For some reason, I am not getting to the chat box. So Mark, if you could tell me again, yes or no? What's the consensus?
We are seeing a few yeses, but the vast majority are no or made up.
Okay, congratulations, you all learned, okay? In 20 seconds. That was 20 seconds of Norwegian and you learned. So how is this possible when adults are supposed to be bad language learners? I'm trying to.
Melbri.
Here we go. Because it literally can be this easy. Well, what you did was a type of learning called statistical learning. And in particular, the statistic you took advantage of was a predictive statistic in the input. So it turns out that every single time you heard the syllable brick, you also then immediately heard k. So you heard brick, after a while you knew k was coming, whether you realized it or not. But on the other hand, when you heard mel, it was followed by Brit only 11% of the time, and your brain automatically tracked this, okay? So it recognized this, because of the predictive statistics, is a unit, whereas this is unlikely to be a unit. Okay, so we wondered what the neurological basis of this kind of learning is. So we had people do this experiment that you just did in a somewhat longer form in the MRI scanner. So instead of one word that they learned, they were going to have to learn 9 words from connected Norwegian speech spoken by a native Norwegian speaker. And they got about 2.5 minutes of Norwegian per scan to learn these 9 words. And then we did 3 scans, so they heard this presented 3 times. Okay. So here's what happened. Let me orient you to this. So basically what we're looking at is the number of times they say yes to a test item. Yes, that's a real word. And when you get a situation where the dark bar is taller than the light bar, it means they're saying yes to real words more frequently than they're saying yes to non-words. And that constitutes evidence of learning. And what you can see is that they learned after 2.5 minutes, they were better than chance at this. And their learning just got better and better as the scans went on. So what does this look like neurobiologically? Okay. What we see with this kind of learning is a widely distributed network of activation. So for those of you, and I know there are a few of you because I saw you come in, who are familiar with fMRI studies, and I'll point out that this is not an activation map that shows you strength of activation. This is an activation map that shows you areas of activation, and the color coding represents areas that are co-activating on the same time work. So there are sub-networks. So the purple here and the purple here is activating on the same time course. This green goes with this green, so they're functionally connected. But if we kind of step back and look at scan 1, you see sort of the classic language cortex. There's superior temporal cortex, there's inferior frontal cortex, it activates. But we also get this frontal parietal network where the parietal system is very likely involved in processing and attention to phonological information. And this frontal network has to do with working memory and memory control. So you get a couple of cognitive systems working together to produce this statistical learning. So the obvious question here is this actually statistical learning, or is this just a side effect of hearing Norwegian speech? And so what we did to figure this out was we had a second group of participants where they got exactly the same input with one critical difference. For all the words that we wanted the listener to learn, they were all 2 syllables. And we took the audio record and we clipped those 2 syllables apart and moved one of those syllables somewhere else in the audio stream. So it's all the same syllables, but all we've done is removed the predictive relationship between the 2 syllables of the real words. Okay? So what happens to the brain where they have the same input, but they no longer have the statistical information? So this is what it looks like. God bless them, they're trying, but their brains just don't have what they need to learn this way. So can they learn anything? Yeah, it turns out they can, because there's other information in the input. There's prosodic information, for example, but it's really, really hard for them to manage the incoming information without the statistical cues. So predictive statistics are one kind of statistic that we get in the input. It's not the only kind of statistic. Another key statistic that I like to look at is co-occurrence statistics. So if you're trying to learn what BRCA actually means, and you hear the word BRCA along with certain other kinds of reference information, you might begin to develop a sense of what BRCA means. So let's just take a look. So you hear BRCA and you see things that are like this. Okay, now you're probably thinking, well, I still don't really know what this word means, but let's find out how much you actually do know. Mark, I'm gonna ask you for your help again. So is BRCA item number 1 or item number 2? Go ahead and put that in the chat box, and Mark, give me a sense of what the consensus is. Okay, Mark, not hearing you.
I am here, and of course you have to take yourself off of mute, right? I am seeing many number ones here.
Okay, there you go. So, in fact, Bricka, I had to look this up for the talk, I didn't know, means peace. So, whereas number 2 is a choya. Okay, so that means that we can actually say a bricka of choya, because here it is, but we can't say a choya of bricka, because that doesn't make sense. Well, given that you've just learned bricka, how do we know this? It's because we have an implicit awareness from the input in our native language that tells us what to expect in terms of the form and content of our language. And there are lots of these distributional pieces of information in the input. So for example, if you hear the word the, you're very likely to next hear a person, place, or a thing. Okay, that the statistics for that are very, very high. So then, but if you hear the word take, for example, you're likely to hear a person or a thing like take your brother, or take the dog, or take the test. But if you hear leave, you may or may not hear anything. So that's why leave, take your brother sounds fine, but leave, you don't have to say leave your brother. Leave by itself is just fine. There are other kinds of non-adjacent contingencies in English where is predicts ing with lots and lots of different verbs in the middle, or singular nouns predict the S verb marker with lots and lots of verbs in the middle. And there's even rules for regular past tense or irregular past tense formation. For example, if you have a soft I or a nasal or a velar sound in the word, you're likely to form the past tense by a vowel change instead of by adding the ED marker. So swim becomes swam, but not swimmed. Ring becomes rang, not ringed. So even for irregulars, which we think of as exceptions, there's actually a rule there. Okay, so the nice thing about statistical learning is that it works rapidly, in minutes rather than in months. It does not require the learner to have access to meaning. Meaning helps when it's there, but it doesn't require it. And learning is retained over time. So there have been a couple of experiments that have tested it months later and found that the learner still knew the predictive relationships. And most important for us, learning generalizes. And you saw this yourself because I never showed you the broken plate when you were associating bricka with potential meanings, but you generalized it to the broken plate right away. Okay. All these things made this really intriguing to me in terms of thinking about treatment. And I want to show you how we've incorporated these principles of statistical learning into treatment contexts. Okay, so I want to start by thinking about what is the goal for child language treatment? What are we trying to accomplish here? And there are kind of two ways of thinking about this. I would suggest that one of the traditional ways of thinking about it is the goal is to have the kids practice saying things right so that they will know how to say things right. So this is a very production-based goal. For statistical learning, you kind of flip that on its head. So the goal here is to change the child's internal representation of their language so they can say things right on their own. And in this case, it's an input-based method of treatment. So the input now is much more important than having the child say things repeatedly. Okay. So before we go translating things into treatment context, we might have a couple of questions like, can people with language impairment even do statistical learning at all? And the answer is yes, but, okay? So my lab has done a number of basic behavioral experiments on statistical learning with children and adults with developmental language disorder. And sometimes they do it very, very well right away, and sometimes not so much. So here's one example where they can do it very, very well right away. So these we did with children and adults. And again, we looked at, this is a prosody processing where they're learning the patterns, the statistical patterns of assigning prosody. The dark bar is generalization of the pattern. This is the correct pattern, incorrect pattern, and then generalizing the underlying principle, the correct principle, the incorrect principle. So again, a difference between the lighter and darker bars indicates learning. And as you can see this, the individuals with DLD can generalize the pattern just fine, and they actually also generalize the underlying principle. So they can do this just as well, if not a little better than the normal peers did. Then we did a study on grammar, and we had them learn a fairly simple grammar. Normal people could learn it with 3 examples of the grammar, and we presented these 3 examples 8 times each. So lots and lots of presentations of these 3 examples. And the normals can learn it. There's a big difference between the dark bar and the 2 light bars. So in this case, there were 2 ways you could be wrong about the grammar. We tested both of them. But the people with language disorders could not differentiate between correct and incorrect. These are not actually significantly different. But then we changed the structure of the input. Instead of giving them 3 examples lots and lots of times, we gave them 24 unique examples. And now all of a sudden they can learn it. So they're accepting correct grammatical things way more frequently than they're accepting ungrammatical things. So in this case, just by restructuring the input, we can turn people from non-learners into learners. And again, this happened within minutes. So again, we asked, do these language disordered learners use the same neural resources when they're going about statistical learning? And I'm going to show you the results of the study that I showed you before, so you have something to compare it to. So it's exactly the same study as I showed you before. Here's the behavioral results. It's a little bit different layout this time. It's a D prime value, which means it's the difference between accepting things that are actually correct and false positives where you're accepting things that are not correct. And in all cases, these are the normal learners. They are better at this task than the impaired learners. So the normal learners are above chance after 2.5 minutes, as our group who did the first study were as well. But the disordered learners are not quite there yet. But by the second scan, they're also above chance. So they can get there. It just takes some more input. So this is what the normals look like, very much like the last one I showed you. I'm just showing you one of the 3 scans. And it's the same general regions that are activated. Now, the big question is, when we look at the disordered group, are they going to look like the normal group? Or are they going to look like those normals we saw before, where their brains weren't even given a chance to use statistical learning? Here's what they look like. Truthfully, if there wasn't a label on these images, I would not be able to tell you which group was which. That's how closely their networks match the normal networks in terms of areas of activation. But if you look a little bit closer, then you start seeing some differences. So what I'm showing you here is a bar graph that shows the amount of activation in the different regions of the brain in the classic language areas. So here's BA44, that's part of Broca's area, inferior frontal gyrus. It shows up in 3 different subnetworks. Supramarginal gyrus shows up in 2 different subnetworks. This is an area that does a lot of attention to phonological information. And then this is the superior temporal gyrus, which routinely shows up for statistical learning tasks. So basically what you see is everywhere there's an asterisk, there's a significant group difference here. And what you see overall is this pattern of the impaired group has to work harder. They're physiologically working harder, their blood flow levels are higher, suggesting more metabolic demand to do the same task as the normals are doing. So it's not that they're learning in bizarre ways, it's just that they're using the same network, but it's less efficient, so they have to really ramp it up to get the job done. So the good news is they can do statistical learning, particularly if you structure the input optimally, and they're using the same learning networks as typical people do. So how do we put statistical learning into a treatment context? So my colleague Rebecca Gomez, who's a big name in statistical learning, and I sat down a couple of years ago and thought about what are the principles that come out of the basic research, the basic psychological research on statistical learning that we can capture as being high potential to put into therapeutic context. And we came up with 4 principles, and we call them the regularity principle, the variability principle, the input principle, and the memory principle. So the regularity principle basically says that if you want somebody to learn something, you need to make that something high frequency in the input and high consistency in the input. And we'll look at this in more detail in a minute. The variability principle says, okay, you've got something that's regular. Vary everything else around that target so that everything is variable except the thing you want learned. The input principle says that input alone can affect output. And we know this from multiple studies where we've actually gotten people to change their output based on the nature of the input they've been given. So for example, Larry Leonard has a really nice study where he can get children to either start producing the participle verbing form or the present progressive is verbing form, depending on whether the person talking to them is using more of one or the other. There's also some really nice articulation ones where if you give kids phonotactic patterns that are rare in English and therefore somewhat difficult to produce for young kids, if you just sit them in front of a computer and play them lots and lots of these rare phonotactic patterns, they start producing them better on their own without ever having practiced them. Okay? The second part of the input principle is that all input is input, that this is implicit learning. So your brain is not regulating input that is correct from input that is wrong. I will point this out because there are published studies where people have purposefully used correction of incorrect input as part of the treatment paradigm. So for example, there was a study where a puppet would say something wrong and the kid would be asked to say whether that was wrong or right, and then the clinician would correct it. Well, from a statistical learning perspective, that wrong input's still input, and it interferes with the ability of the learner to detect the overall pattern. Finally, the memory principle says that basically, in order to change your conceptualization of your language, you have to get the statistics coded into memory. So reactivation of memory is important for this. And then effortful recall is also important. So I'm going to show you examples of both of those as we go along. So here's the regularity principle put into a treatment context. So this actually came from some late talker vocabulary treatment that a colleague of mine, Mary Alt, does. And you should be able to pick out the target of learning here because it is the most frequent and the most consistent thing in the input. Here's your shoe. Look, one shoe is blue. Shoes go on feet. This is a small shoe. Dolly's shoe is here. He needs a shoe. I found a shoe in here. Shoes are for walking. This shoe doesn't fit. I like a shoe. And then lots more of these. And it turns out that you don't have to make kids say anything, that late talkers who have very, very low vocabulary will start picking up these words and using them productively just from the input. Here's an example from grammar, and I've set this up to go along the lines of a conversational recast type treatment. So a recast treatment follows this form. A child says something that attempts to use a part of grammar that you're trying to remediate. The clinician repeats the child's utterance, correcting ungrammatical parts of it. That's called the recast. And then the clinician will go on to kind of set the child up to attempt to use the grammatical target again, so he can recast again. So here's an example. So this child says, he jumped in. The clinician corrects that, he jumped in, so we can assume that the clinician is trying to model the past tense ED marker. And then he goes on to set up for the next utterance, and he chased the car. He's going to crash. Watch him crash. What happened? And what does the kid say? He did it. Let's look at why he didn't try the past tense. You've got one past tense marker here. You've got another one here. But you've got he. So he is the most frequently occurring thing in the input. And in fact, we know that nouns and pronouns are easier to learn than verbs from normal child language development. So you have given the kid a competitor to what you're trying to get him to learn by making something else the most regular thing in the input. And that's why the kid came back with he did it instead of trying to use crashed. Okay, so this is actually my favorite example. It really happened in a treatment study with a student clinician who was treating a young child. And she was doing recast in the context of reading a book, and the book had a lot of surprise changes in it. And so here was her input. Oh my gosh, the cat turned into a bat. Next page. Oh my gosh, this bug will turn into something. Let's see what. Oh my gosh, what happened? And what do you bet the kid said? Yep. And as soon as that happened, the clinician realized what she had done, fortunately, and corrected. But it took a while to get the kid out of that set because they had encoded so many oh my goshes that they thought that was the target. Okay, so the message here is pay attention to the little things, lest those little things become the big things. So we're trying to get the kid to concentrate on the dogs, but we've put so many birds in that is the most regular and frequent thing in the input. Okay, in the chat box, go ahead and put in a couple of words on what does the regularity principle say about learning. And I'm going to give you a minute to do that. So just a couple of words to kind of cue your memory about what the regularity principle is all about. Okay, Mark.
Okay, Dr. Plante. Yes, we are seeing the words frequency and consistency often here, and then coupled with high frequency, high consistency.
Fantastic. And that's good enough. That's all I need to know, because the point of this is the memory principle in action. This is it. So I waited a while, and I had you pull that information up on your own. That action of pulling that information up, which was probably just a little bit effortful, does two things. First of all, when you reactivate a memory, it makes that memory labile. So it is vulnerable to change at this point. And if we put correct information in there, we can form a new memory, and you don't even realize it's happened. But if you correctly pull it up, you're strengthening that memory in your recall so that it's available for use later. So that is the memory principle. You just did it. Okay, on to the variability principle. So the variability principle says that once you've got something that is highly frequent, highly consistent in the input, in other words, regular, okay, then you want to vary everything else around that target. So let's look at an example from grammar. So in this case, we're trying to train is verbing, so the present progressive. So the input to the child is Joey is throwing the ball to his dog. His dog is running after it. The dog is jumping up. The dog is catching it. The dog is trotting back to the boy, and the dog is laying down next to Joey. So the problem with this input is that we have two competing targets that are both equally regular. We have is predicts ing, and we have dog. And that given that nouns are easier to learn than verbs, dog is going to be learned. And probably the kid already knows dog. So that's a wasted opportunity. So there, I fixed it. Okay, so Joe is throwing the ball to his dog. Now dog is done. You can no longer use dog. You got to figure out other ways to talk about the dog. His pet is running after it. Rover is jumping up. He is catching it. The good pup is trotting back to the boy. Joey is taking back the ball. Okay? So one of the major errors I hear from new clinicians who are trying to implement this way of doing therapy is they forget about pronouns. And I'll have to go into the therapy room and say, I'm hearing a lot of he. He did this, he did that, he did the next thing. Okay? You are banned from using the word he from now on. You got to find other ways to talk about Superman. So Superman, the good guy, the hero, you know, just find other ways to talk about it so you're not saying he. Okay, so let's put this into an actual therapy context. So what we did when we started this line of research was we took an existing therapy that does work. It does work. There's a meta-analysis on it, and it does work. But my concern was that the published papers on this therapy, it took a long time to get kids a little bit of the ways. So for example, the two most recent publications using conversational recast therapy, in 6 months, they moved kids from 0 use to 50% use, and these kids were treated 4 times a week, every week. That's a lot of therapy over a long period of time. So I'm trying to make this faster by incorporating statistical learning principles. So we're going to incorporate the regularity principle by training one grammatical target at a time. And this was actually not new for conversational recasts. There was already a publication out of Vanderbilt showing that if you try to target multiple things at the same time, kids learn nothing. And from a statistical learning point of view, it's because nothing is regular. Okay, the variability principle, we're going to vary all the other words around the target of learning. The input principle, we're going to have clinicians provide models during the recast of what the correct grammar is. And the memory principle is actually because in conversational recast, we set the child up to try to use that target morpheme, which means that there's some effortful recall by the child to try to retrieve that grammar and use it. So let's look at an example here. You're going to see the clinician set the child up to use her morpheme with the word saw, okay? And then you'll see the recast.
I think this piece is a little too big. Watch me saw it. Watch me saw. What happened?
You saw.
I sawed.
Here, you beat that. I beat this.
Okay, so that's basically the way it goes. Pretty easy to do. The kids like it. So how important is high variability input? I will tell you right now, it's possibly the most important variable we've ever tested, ever. Okay, so what we did was we did conversational recast with 4- and 5-year-old children with developmental language disorder. They got 25 sessions. We treated one morpheme. It was not the same morpheme for every child. It was whatever they didn't produce. And then we tracked a second morpheme. That second morpheme, we didn't treat it, but we just tracked it because if the kids had a sudden maturational bloom, it would affect both the treated and the control morpheme. But if the treatment was really responsible for progress, we should only see change on the treated morpheme. And then, importantly, we tested the children's use of their morpheme with words that were never used in treatment. So that's true generalization. So this is what happened. Half the kids got 24 unique examples, once each. The other half got 12 unique examples, but each example was repeated a second time. So everybody got 24 recasts. Everybody did. But half of them got half the number of distinct exemplars. And when you got 24 unique exemplars, we can move you about 2 standard deviations off your starting point in 25 days. Not 6 months, 25 days, right? But if we only gave you 12 examples, even though we give each of them twice, you only move about a half a standard deviation. So this is a huge difference just by adding variability into the input. Okay, so here's some pro tips for you guys who are clinicians in the audience. What we do is we go ahead and pick our materials that we're going to work with first. Then we look at the materials and write down 24 targets that can be used with those materials on a piece of scrap paper, okay? And then in the session, we just simply cross those off as they're used so that by the end of the session, we know we've gotten the minimum number of effective doses, which is 24, in that session, and that they were 24 different doses, okay? And then the next session, the kid comes in, we pick different materials, because picking different materials will naturally make you pick different words. So for example, if I'm treating past tense and I pick a craft material one day, I'm going to use words like snip and glue and press and paste and color. But if I read from a book that's about a baseball game, I'm going to use words like hit and run and catch and field and things like that. So just by varying the materials, I'm automatically going to vary the verbs. And I can and have done this with the contents of my purse. So it is not hard to do. It just takes a little bit of a shift of your mindset. So again, in the chat box, we're going to do this quickly. How do you implement the variability principle in therapy? Just a few words. Okay, I'm going to actually trust that you did this because the memory principle is for your benefit, not mine, and we'll move right on. So one of the big problems in treating language disordered children is that the complaint is, well, they do it in my therapy room, but they don't do it once they leave my therapy room. Well, there's a whole thing about place-specific learning, which unfortunately I can't get into right now, but maybe somebody will have a question about it. But I can tell you for statistical learning, generalization is not a problem. It's not a problem in the basic literature. It's not a problem in the therapy context. And this is data, it's in press now. Actually, the preprint is already out in AJSLP, where we tracked children's in-treatment performance, that's the dotted line, and their generalization of their morpheme use over time, over treatment days. And what you can see is that people start out neither using it in treatment nor generalizing it, and those two functions grow together over time. So there is no special planning for generalization. It happens naturally because what you've done is change the child's internal representation of their grammar. You might also wonder, well, does this learning last or does it fade away? And the answer is yes, that however much learning they ended with, if we bring them back 6 to 8 weeks later, they will come back with the same amount of morpheme use. So if you didn't do well with this treatment and you left with, say, 20% use, you come back with 20% use, which is better than the 0 you started with, but you're not getting any better. And if you ended with 90, 100% use, you will come back with 90, 100% use. Now, here's the caveat. a lot of goals are written that a child will use their grammatical feature 80% of the time over 3 consecutive days or in X number of opportunities or something like that, with 80% being some kind of magic number. If we just get them to 80, they'll close the gap on their own. Well, no, they don't. They don't. If you leave them at 80 and bring them back 6 to 8 weeks later, they will still be at 80%. So if you want something fully remediated, you have to take them to 100% there, make sure they're stabilized, and then send them on their way. Okay, so you might be saying, if you're a clinician in the schools, well, you know, that's all well and good for you in the ivory tower to be scheduling kids individually. I need to schedule my kids as groups. So we asked, do kids benefit from group treatment? And the way we did this was exactly what we did before, with one change. We had kids either assigned to groups of 2 or as individuals. And before you say, oh, I'd be happy to have a group of 2, I'll tell you why we did groups of 2. We did groups of 2 because we specifically wanted to know if children benefited from what they heard directed to other children. And to just manage that logistically, we chose children where you had pairs of children that had 2 morphemes that neither one of them could produce. And then for the first child, you might treat like plural S. And the second kid needs plural S too, but we didn't treat that kid for plural S. We treated that kid for present progressive, so is verbing, okay? So we direct doses involving plural S to one kid and is verbing to the other kid. But both kids hear both doses, okay? And then we can ask, well, does being in a group benefit you, or does it even matter? So kids in groups are slightly worse off for the morpheme they're treated for than kids who are seen individually, but this is not actually statistically significant. So groups, not groups, seems okay at this point. Now let's take a look at this critical variable of, do kids benefit from the doses directed to the other kid in the room? And the answer is no, that there is basically no movement of that morpheme. So this is the difference between a dose that is directed directly to the kid and a dose that is somewhere around them in the room. They do not benefit from doses that are around them. They benefit doses directed to them. So this takeaway point here is, a dose administered is not the same as a dose received. That the dose actually has to go into the kid for it to make a difference. And these kids, you know, attention is a problem for them. So one of the things that we do is we go to great lengths to make sure that they are visually attending to our faces at the time we provide the recast. And that seems to make a huge difference, because the effect sizes from the first study where we didn't do that to the subsequent studies where we did that went from about 2 to about 5. Okay, so the next logical question would be, well, how do I schedule all my kids individually? I got too many of them, okay? Well, one of the things that we thought of is, what if you make the sessions shorter? Now, conversational recast, when it was initially conceived of, the reason why people thought it worked was because language happens in this naturalistic conversational interaction. And we thought, you know, from a statistical learning standpoint, the naturalistic conversational interaction is actually beside the point. It's the input. So we tested out this idea that giving the same number of doses in half the time would still result in strong learning. And here are the kids who got their conversational recast in 30 minutes, and here are the kids who got it in 15 minutes. And again, these are not actually statistically significantly different, mostly because there's so much variance here. But basically, you're talking about moving a kid, you know, 6 standard deviations off his starting point in 15 minutes over 25 sessions. So that's pretty good. And I will also say we've done extremely abbreviated sessions with articulation therapy, where we take the articulation session down to 5 to 8 minutes, 24 doses in 5 to 8 minutes. and we can get progress that way. And frankly, with a 5-minute session, I wouldn't even bring them back to the speech room. I'd pull them out of the classroom into the hallway, do their rounds, stick them back in. And that way, they're not missing instructional time, sitting in a group, waiting for the dose to come around to them. So although group therapy may not hurt kids in terms of their language goals, it's certainly hurting them in terms of missed instructional time. So the take home from this study is dose does not equal time. A dose is a therapeutic action. So dose is a count noun, not a mass noun. Okay, so there is nothing magical about simply being in the presence of an SLP. So if you have a lot of time between when you administer a dose to this child and when you cycle back around to that child to another dose, that's wasted time for him, okay? And I will say to the students who are in the audience, it's also not about the game or activity. I know you all put a lot of thought and effort into the games or activities that you're using with your kids, but it's not actually about that. It's about the therapeutic action. And if you can't actually express what is therapeutic about what you're doing, you're not doing therapy, you're doing babysitting, okay? So how to get to session time, because on the IEP, you're gonna have to put in how much time you're gonna give services to the child. So how do you calculate that? Well, the session time is equal to the minimum effective number of doses. So for training grammar, it's a minimum of 24 unique doses times the time it takes per dose. So in conversational recast, it takes less than a minute per dose. So you can get 24 recasts in 15 minutes. That's less than a minute per dose. So you just multiply those two things out. That's the amount of time you need. Okay, pop quiz. Ready with the chat box. Which one of these items, item 1, 2, or 3, is a choya? So go ahead and put that in the chat box. And Mark, tell me what you're seeing.
Dr. Plant, we are seeing many number 1.
Excellent. So how in the world did you all do that? And did you even know you were doing it? Because I was kind of tricky about this. So over the course of this talk, I actually gave you 3 doses of the word choya. On the opening slide, I pointed out that these were choyas. This was the foil to bricka. And then I said the piece of choya here. So you got 3 doses. But notice how I incorporated variability into the input here. So at this point, you can't vary the word because the word is the word, but you can vary the referent. And in 3 doses with varied input, you guys came up with the right item and generalized it to a picture I'd never shown you before. So we did this with children with DLD, 4 and 5-year-olds. They also had 3 treatment sessions. This time we asked them to learn 8 unknown words. We did not use cactuses because Arizona children know the names of cactuses. We used words like hinge, doily, tassel, things like that that they didn't know the names of. They got 6 doses per word. Half the kids got varied input. Half of the kids got 3 examples, but they were physically identical examples. Here's what happened. So at pre-test, nobody knows any of the words because that's how we picked them. Test 1, both groups are learning. They continue to learn. They continue to learn. No difference here between groups. But then we bring them back a couple of weeks later. And this is significantly different. So the kids who got the high variability input, if anything, they seem to be consolidating their knowledge a little bit. Their performance goes up a little bit. The kids who have low variability, no variability really input, they're already forgetting, okay? So should you incorporate object variability into vocabulary training? Well, only if you want them to remember the words you're training. Okay, so how different do the examples have to be? Well, they have to be different enough that you can differentiate between what's a defining feature and what's an unimportant feature. So for example, if a child has never encountered a dog, and I only give them golden retriever examples, they may incorrectly infer that the color of the fur and the length of the fur is somehow defining to the word dog, okay? But if I give them varied examples, then what they do is they figure out pretty quickly, oh, color is not important, hair length is not important, but 2 eyes is important, ears set above the eyes, that's important, 4 legs, that's important, tail is important. And they will notice those things that are consistent across the examples and disregard the things that are free to vary. Okay, so dose variability. So for morphosyntax, again, you need 24 utterances minimum. And for vocabulary, it looks like you need a minimum of 3 different objects or reference. Okay, so I just reactivated that memory for you to reinforce the correct information. I will just point out here that there's nothing special about oral language. It also works for literacy. Here's an example where you have low variability frames and high variability frames, and it should be no surprise at that point that the people who got high variability frames for learning vowel spellings outperformed people with low variability frames. Okay, so the take-home message here is how you structure the input during treatment really matters, okay? And you have to ask yourself, what state do you want your learner's brain to be in during treatment? Do you want their brain to be in a state where they have a lot of resources working in coordination on this problem, or do you want them to have this brain that is struggling to understand what it is they're supposed to be latching onto? And with that, I will take final questions.
Thank you so much for your time and talents and energies, Dr. Plante. There are a few questions have come through. One is if you could talk with us a little bit about the influences of other cognitive deficits relative to the clinical methods that you're discussing here. So are there groups of children, perhaps for whom statistical learning principles are not recommended?
Actually, we don't know that. We do know, for example, the kids with autism do this better than kids with language disorders. So it does seem to work with them. And it has this huge benefit because there's no inherent production demand. A lot of these kids tolerate it a lot better than high production kinds of therapy. So that's been done in our own clinic, not as a research project, but we definitely have had people apply it in our own clinic, and that's what we find. But I can't tell you about people who can't do this. I don't know any groups that literally just can't do it.
Okay, thank you for that. I appreciate that. Another question that's come through here is, can you talk with us about a child who may just not be responding to this form of treatment? And is there a different direction to take or advice you can give us? Should that run our way?
Every single treatment study has non-responders. Every single one. Mine does, everybody else's does. And basically we've been ignoring them. So our group has started to decide to not ignore them anymore. So one of the things that we've done is we're coming out, the preprints are just now available to tell you how to predict who's going to benefit from this treatment in terms of their test score background in morphosyntax. And it turns out vocabulary test scores also are predictive. And also in terms of things that happen in the treatment session. So basically, if kids will give you at least one correct response within the first 10 days of treatment, that's a kid who's likely to go on to have a good response. If a kid starts repeating the recast after the clinicians delivered it, that's a kid who is going to start using their morphine correctly within, on average, 2 sessions. So there are these markers that you can tell fairly early on who's going to be a treatment responder. Now, what to do if they're not a treatment responder? That's the $600 million question. I just submitted a grant literally today that incorporates that as part of its purpose. So stay tuned is what I'm going to say.
Thank you very much for that, Dr. Plante, and for everything you've shared with us this evening. I see that we're coming on about 5 minutes past the hour. And so I certainly want to be respectful of everyone's time and make certain, Dr. Rousseau, do you have any parting words this evening for those who are attending?
Mark, we can actually leave the Q&A open for a bit longer since we did go over. And those who need to log off can feel free to jump off. I do see a question that I will try and paraphrase and pose to Dr. Plante, and that comes from Will Evans. And the question, Elena, is about applying the memory principle in terms of dosage, maximizing the number of trials and the limited number of time you have during your treatment. Is there research on how this relates to practice scheduling in terms of massed versus distributed practice?
Yeah, there's actually been several studies on mass versus distributed practice. And part of the problem with this literature is it's hard to hold everything constant while you're just looking at mass versus distributed. So basically, the ones that have not held constant total treatment time, the period of time over which treatment occurs, suggests that distributed practice might be better than mass practice. But there's been one study that actually held constant everything, including total treatment time. So the way they distributed practice was they distributed it throughout a day. And in that case, it did not matter whether it was massed or distributed.
Great, thanks. And then related to that, just 2 questions. How does this principle, learning principle, interact with variability of stimuli? And then also, would group therapy be a way to distribute practice in real-world contexts and use speech-language pathology time more efficiently?
Well, again, group therapy, the variable there is whether or not kids can do simultaneous doses. So there are kinds of things we remediate where kids literally can do simultaneous dosages, like writing or narratives, that you can actually treat kids simultaneously for that. If you are treating things like articulation, it's really, really hard to do simultaneous dosages because you end up with some kids who get it and some kids who don't, and then the feedback doesn't work for both sets of kids. So you have to ask yourself in group therapy, what is the time going to? And is it more effective to treat kids in a massed amount of doses in a short amount of time and then get them back to their regular programming, or allow them to sit around waiting for the dose to come around to them again? Because as I said, there's nothing magical about being in our presence. It's about getting the doses in. So I've already forgotten the other part of that question. Bernie, could you recap the part I missed?
If group therapy was a way to distribute practice in real-world context.
Oh, okay. So let's say you're doing push-in therapy, okay? And so the kids are naturally grouped, but you're not necessarily treating all of them. Yeah, you can push in different times of the day, but as I said, it doesn't seem to matter. That if you treat all at once within a day or spread those doses all out across the day, that doesn't matter at all. What does seem to matter is when you dose, when you distribute the dose across a longer period of time. So same number of doses, same number of treatment sessions, but those are distributed over a longer period of time. That seems to be more effective overall than massing the treatment sessions.
Okay, and the next question is from Catherine, and if you've already covered this in your prior response, feel free to say so. If not, okay, feel free to elaborate. And that is, how much production is required for the treatment?
Required. None. Really, literally none. Because we have seen kids, for example, the other half of my current treatment grant treats late talkers. And, you know, by definition, these kids aren't talking to us. That's why they're late talkers. And we have no production demands on them whatsoever. And we can make their vocabulary trajectories grow faster than they would if they were normally developing kids with no production demands at all. With the kids who are seen in our clinic with autism, there are no production demands at all there. Now, if you've got a kid who can produce, again, giving them opportunities to produce and activate that memory through effortful recall, I do think that is actually helpful. But whether it's required or not, or whether you can do it without it, we actually have plenty of evidence now from both treatment research and from experimental studies that show you can change production without having kids practicing production.
Thank you. And the next question is from Jesse Van Sweringen, and that is related to fMRI. Can you explain if an fMRI with little activation, a struggling to get it brain function, or a not engaged brain?
Yeah, a not engaged brain, you just don't see the same learning networks that you see with a brain that's engaged but struggling to get it. So over a number of different studies that have looked at disorder groups versus normal groups, if you have a task where the disordered group can't do it, what you tend to see is underactivation of brain networks because they just can't do it. And that's kind of similar to that first study where I showed you the highly active brains versus the really very little activation in the brains, because they can't do it. So there's nothing for their brain to latch onto. But when people can sort of do it, or so that they are somewhat successful, but maybe less than normal, or they eventually get there, they just need more time and effort, what you tend to see is overactivation of the learning network. And we've seen this in developmental language disorders, we see it in dyslexia. There's a few examples across disorders where that's the pattern, that overactivation happens when the brain can kind of do it, underactivation happens when the brain just can't do it.
Great, and Dr. Chandrasekaran says, great talk, curious about the underlying mechanism. Is it possible that high variability is just desirably difficult? That is, it pushes the child towards an internal state, example given greater arousal or attention, that is more receptive to generalizable learning?
Mm-hmm. Yeah, I like the concept of desirably difficult, but I actually think that this works in a very different way. I think what the variability around the target does is serves to make the target salient. So basically, if we've got input coming in and we know we're supposed to do with it, our default mode is try to remember everything, okay? But if you have so much variability that you cannot remember everything and you're overwhelmed, you've simply overwhelmed the memory system, what will happen is the pattern recognition system will try to latch on to something. And what it'll latch on to is those things that are regular. And this comes straight out of a 2002 article by Rebecca Gomez that showed that high variability input tends to make what is regular highly salient so people can find it.
The next question is a COVID-19 related question, so if you could channel your inner Dr. Anthony Fauci. Jenny Coyle asks, you made the point that direct eye contact with the child looking at you is important for statistical learning. So she asks, what effect will masks have which cover the mouth or service delivery by telepractice?
You know, I think that is a potential problem that's going to make the learning harder. I don't think it's going to make it impossible, but one of the things we know about children with developmental language disorder is they can give us a McGurk effect, which means that they can do audio-visual integration. So a McGurk effect occurs when your lips are saying one sound, but you hear the mouth say a different sound. And what happens is your brain integrates it into a third sound. So if your lips are saying B and you're saying G, the listener will hear D, okay? That tells us that the brain is integrating what they see and what they hear. And kids with DLD do this. So having the visual signal with the audio signal is definitely helpful for them, but only if they're looking at you. And let me tell you, I mean, we talk about autism and gaze avoidance, but oh my God, do I see gaze avoidance with these kids all the time. And what they do is they look away just when you're given the recast because they know it's coming. So you get kids who go like this, like this, or their eyes will suddenly go, so they're no longer looking at you. So that's a big problem. I actually thought that question was going to be, well, can you do this virtually? And we have actually done it virtually, and the answer is yes, you can. You can do it over Zoom.
Great, thanks. And so it looks like we have time for one more question. I'm going to, or maybe one or two questions, and I'm going to ask this question on behalf of Kathy, and that is, if individualized treatment has proven the only way this is shown effective versus group treatment, how does this affect or impact mainstreaming / inclusion within the schools?
Okay, it's not that group treatment is not effective. It's just as effective as individual treatment. But if you're pulling kids out for group treatment and they get no benefit from anything else that's going on around them, then you've got a cost to that pullout. It doesn't say anything about treating in place.
Great. Okay, thanks for the clarification. Dr. Dickey says, thanks for a fantastic talk. And he'd love
Thanks,
to hear,
Mike.
He'd love to hear more about the place-specific learning effect you mentioned in passing, and specifically what treatments are most vulnerable to that effect, and if our statistical learning treatment approach is less vulnerable to this effect. I'm reading, so apologize.
Yeah, so place-specific statistical learning treatments seem to be less vulnerable to place-specific treatments because when we bring these kids back for follow-up, we bring them to a completely different building, and they still are showing us that they come back with what they leave. So that's the good news. So what place-specific learning is all about is, this comes out of the memory literature, and again, I'm going to go to my go-to gal. Rebecca Gomez has done some of this work. So I'll give you an example of a study. So they had people come in for a memory study, and they went into a room and they memorized a list of things, and then they were sent on their way, and then they were brought back on a different day. And they were 3 groups. One group went back into the room that they first memorized the information in. One group was put into a different room, and a third group was walked past the room they learned the initial list in to the room they were then tested in. And the performance was in this order good. The room you learned it in, walking past the room you learned it in, and a new room. So basically, there's something about the being in the context that you originally learned something in reactivates the memory for that information. So if you are doing very explicit teaching methods for treatment, so not everything is learned statistically, but lots of things that are even taught explicitly can benefit from statistical learning principles, like we saw with literacy. But basically, if you're doing a really explicit method, and particularly one that involves a lot of memorization where people have to think about what they're doing, if you remove them from the place where they learned it, they're likely to do less well than if they're performing in the place where they learned it.
Right, so Elena, I'm the voice expert on the call, and I hear your voice getting a little hoarse, so as also the moderator and co-host, I see you're hydrating. I will take the liberty of wrapping this meeting up, and I'll just end with probably home summarizes it well. That's home in the group chat. He or she says, so interesting. I was not prepared to be energized by this information tonight. Appreciate this talk so much. I want to just amplify that sentiment that we really appreciate your time with us this evening and the wonderful talk you gave and your time answering questions. And we look forward to you joining our research roundtable on Wednesday with our PhD students, postdocs, and faculty. And again, tomorrow, look forward to you joining our faculty meeting as well. So thank you.
It was my honor, great questions, and I was honored to do this lecture. Thank you.
Thank you.